Hello everyone. So in today's video we are going to discuss some of the important functions of number theory, in which number one is Euler's function. It is denoted by phi of n. We have discussed this function multiple of times. You will get all the links in the description. So this Euler's functions tell us about number of natural numbers which are less than and co-prime to this number, and the general formula which you can use to find the number of natural numbers which are less than and co-prime to this number is, first of all you have to factorize n. Suppose if we are factorizing n, and we can write this n as p to the power a, q to the power b, r to the power c, and so on, where this p, q, r are prime numbers and a, b, c are positive integers. So this phi of n is equals to n 1 minus 1 by p, 1 minus 1 by q, 1 minus 1 by r, and so on. Okay, here the formula is independent of these powers which we have put on p, q, r. For example, let's say if we want to find out phi of 100. So the first step which you have to do is factorize 100, and you will get 50, 2, 25, 5, and 5, 1. So I can write 100 as 2 to the power 2, 5 to the power 2, where 2 and 5 are prime numbers, and we have power of these prime as 2. So we can apply the formula of phi n, which is phi of 100 is equals to n. Here n is equals to 100, p is equals to 2, q is equals to 5. Further, you will get 100 into 1 by 2, 4 by 5, 250, and 40. So basically here are 40 natural numbers which are co-prime to this 100. For more examples you can visit the link. Okay, moving on. The next formula which you can use for finding the Euler function is, if suppose I have a number, let's say a. If I can write this a, or let's just take phi of mn. Suppose this number is mn, product of m and n, and m and n are co-prime number, or you can say that GCD of m and n is 1. So you can write it separately, like phi of m into phi of n. Now for example, okay, let's just take the third point before the example. If we want to find the Euler function of any prime number, or you can just write it as a p, where p is a prime number, it's always p minus 1, where this p is any prime number. If you take 7, the answer would be Euler function will give you 6. 3 is 2, phi of 11 is 10, and so on. Euler function of any prime number is p minus 1. Now suppose the Euler function, we have to find the Euler function of 35. So I am splitting this 35 in such a way that the GCD of m and n should be 1. So I can write 75 as 7 into 5. Now we know that the GCD of 7 and 5 is 1. So we can write it separately, phi of 7 into phi of 5. Now we just discussed that prime Euler function of a prime number is p minus 1. So we got 6 here and 4 over here, which is 6 4s are 24. So you saw how simple is this to find the Euler function when you know second and third point. This first formula will work in all the cases, and second and third will help you to find the Euler function in much easier and in a less time consuming, if certain conditions are justified. Now let's discuss some of the important results of Euler function, in which number one is, if I say m divides n, so this will always imply that phi of m will divide phi of n. For example, let's say 2 divide 4. Now this will imply phi of 2 will divide phi of 4. Let's check it. Phi of 2, as 2 is a prime number, so I will get 1, and phi of 4 will be 2. Okay, so we know that 1 always divides 2. Okay, you can check any number. If m divides n, you can always say that phi of m will divide phi of n. Second result is phi of n will always divide phi of nk. Here k belongs to positive integers. Okay, I can prove this like we have a simple result. As I said, if n and k, the GCD of n and k is 1, which means they are co-prime numbers, so we can write it as phi. Euler function is multiplicative. When this condition holds, I can write this as phi of n into phi of k. Now you know that phi of n will divide this because you are getting some multiple of phi n. This will always divide. What if in case n and k, GCD of n and k is not 1? So I just said that if m divides n, the Euler function will also divide each other, as we know that n will always divide nk. So this will imply phi of n will divide phi of nk. Third result, phi of n, if phi of n divides n, then it will always imply that we can write this n, this number n, and can be written in the product of at most 2 prime number, which means if phi n divides n, then n can be written as product of 2 prime numbers. Okay, there can be power of p1 and p2, but there will be only at most 2 prime numbers. Our next function is tau function, and this tells us number of positive divisors of n. Again you have to do same thing. If we want to find the tau of n, so factorize this n. Suppose the factorization is p to the power a, q to the power b, and r to the power c, so on. Then simply you have to take the powers. Tau n will be defined as a plus 1, b plus 1, and c plus 1. For example, let's find out tau of 12. Factorize 12, you will get 2, 6, 3, 2, and 1. So I can write 12 as 2 to the power 2, 3 to the power 1. Tau 12 will imply that this is equals to 2 plus 1 into 1 plus 1, which is 3 into 2, and that implies this is equals to 6. Let's find out whether how much number of positive divisors we get of 12. So 12 is divisible by 1, 2, 3, 4, 6, and 12. And see, this tells us number of positive divisors, which is 6. Now our next function is sigma n. Sigma n tells us sum of positive divisors of n. Similarly, we will find the factorization of n. Let's say it's p to the power a, q to the power b, and r to the power c. So sigma n is defined as p to the power a plus 1 minus 1, p minus 1, then q to the power b plus 1 minus 1, q minus 1, c to the power r to the power c plus 1 minus 1, r minus 1. Let's take the same example. As we have factorized 12, we got 2 to the power 2, 3 to the power 1. Let's find out sigma n. This is equals to 2 to the power 3 minus 1 by 2, 2 minus 1. Then 3 to the power 2 minus 1 by 3 minus 1, which implies 7 by 1 into 8 by 2, and that is 24. So the sum of these positive divisors is 28, which gives us sum of positive divisors of n. Our next function is, if we want to find the product of positive divisors of n. In the previous function, we saw that if we want to find the sum of positive divisors, we can go for sigma function, and in case of product, we will use the formula tau n to the power tau n by 2. Suppose we are finding product of positive divisors of 12, then 12 to the power tau n, that was 6 by 2, that is 12 to the power 3, that is equals to 1728. So in case we find the product of these positive divisors, we will get 1728. So these are some of the important functions of number theory, and if there is any doubt or any query, please do let me know in the comment section. Thank you.